Hello students, let us continue with the topic rational numbers. In the previous videos, you have already discussed the addition of rational numbers, subtraction of rational numbers, multiplication of rational number, division of rational number, and how to insert two rational numbers between two given numbers. Now in this video, we are going to discuss about terminating and non-terminating decimal and recurring decimal as a vulgar fraction. So let us start with terminating and non-terminating decimals. What is terminating decimal? A decimal number that contains a finite number of digits after the decimal point, that is, we get the remainder as 0 on dividing. For example, the answer of 1 upon 2, that is, if we divide 1 by 2, we get the answer as 0.5. And if we divide 17 by 100, so we get the answer as 0.17. So these are terminating decimal. A non-terminating decimal is a decimal number that continues endlessly. That is, we don't get the remainder as 0 on dividing. So digits after the decimal may repeat or may be all different. Student, this is what you need to remember. That in case of non-terminating decimals, that the digits after the decimal, they can be either same or they can all be different. For example, if we divide 1 by 3, we get the answer as 0.333, so on. So in this case, the decimal after the digit, that is 3, will repeat. It will repeat continuously till the end. So we can write it to be like this also, 0.3 bar. The next example is of 0.272727, so on. Now in this case, the digits after the decimal, that is 27, it is being repeated so many times. So it can be written as 0.27 bar. We are going to put the bar on both the digits. At both the digits, they are being repeated. Now the third example is 0.43433, so on. Now in this case, no digit after the decimal is being repeated. Instead, one digit is being added again and again in the next step. Square root of 3, it is equal to 1.732050, so on. It will continue till the end. And the value of pi, that is 3.1415926535, so on. Now students, in case the fraction is a terminating or a non-terminating, we can even tell it without the actual division also. For that, we just need to see that the fractions in which the denominator is in the form of 2 raised to power n or 5 raised to power m, or it is in the form of 2 raised to power n into 5 raised to power n, those fractions will be the terminating one, and the fractions in which we get any other number other than 2 and 5, those will be the non-terminating ones. For example, 1 upon 8. In this, 1 is the numerator and 8 is the denominator. So if we see the denominator is 8, which can be written as 2 cube. So in this, the denominator is containing only 2 as a prime number. So it will be a terminating one. The other example, that is 3 upon 25. In this, the denominator is equal to 25, which is equal to 5 square. Now in this case, we have just got the prime factors as 5 only. So it will be a terminating one. Now in the next case, it is 7 by 10. The denominator here is 10, which will be written as 2 raised to power 1 into 5 raised to power 1. Now in this case, we have got the prime factors of 2 and 5. So this will also be a terminating decimal. So in short, we can say the denominators which can be represented in the form of 2 raised to power n or 5 raised to power n or 2 raised to power n into 5 raised to power m will be the terminating decimal, and all other fractions which will be having a prime factors other than 2 and 5, they will be a non-terminating decimal. So let us discuss some example based on this topic. So without actual division, check fractions are terminating decimals or not. The first one is 11 upon 20. So here the first thing that we are going to check whether the given fraction is in its simplest form or not. If the given fraction is not in its simplest form, so first of all we'll do the cutting and then we'll see the denominators. Now here the fraction is in the simplest form and here the denominator is equal to 20. So the prime factors of 20 will be 2 into 2 into 5, that is 2 square into 5 raised to power 1. So it is in the form of 2 raised to power n multiply 5 raised to power m. So therefore it is a terminating one. The next example is of 43 upon 60. Now in this example 43 is the numerator and 60 is the denominator, and this fraction is also in its simplest form. So we are going to write denominator is equal to 60 and the prime factors of 60 are 2 into 2 into 3 into 5, which will be equal to 2 square into 3 raised to power 1 into 5 raised to power 1. Now students, here we have got, instead of 2 and 5, we are getting 3 also. So this statement is not in the form of 2 raised to power n multiplied by 5 raised to power m. So therefore it is a non-terminating one. So students, let us have a recap of whatever we have done till now. So numbers, there are two types, whether they will be terminating one or a non-terminating one, that is a fraction solely. So terminating one, they are called as the rational numbers, and non-terminating one, they are of two types. The first one is repeating and the second type is of non-repeating. Repeating, they are also called as the recurring one. So they are also the rational numbers. And the non-repeating, they are called as the non-recurring and they are also called as the irrational numbers. So now let us discuss how we are going to convert the recurring decimals into a rational number. To express recurring decimals as a rational number, that is also called as a vulgar fraction, there are some things that we need to see. When one digit is being repeated, for example, that is 1.777, in this, there is only one digit after the decimal that is being repeated, that is 7. So we are going to write it to be like as 1.7 raised to bar or 1.7 bar. So in this case, only one digit is being repeated. So we are going to multiply with 10. Now in the other case, if we see the example is 2.131313, so on. Now in this case, there are two digits after the decimals which are being repeated, that is 131313. So which will be written as 2.13 bar. Now in this case, since two digits after the decimal they are being repeated, so we are going to multiply by 1000. Now the next example, 1.243 bar. Now in this case, three digits are being repeated. So for that, we are going to multiply with 1000. Now students, you are going to remember this thing. In case only one digit is being repeated, so we are going to multiply with 10. If two digits are being repeated, so we are going to multiply with 100. Now in case three digits are being repeated, so we are going to multiply with 1000. Now let us look at an example that how we are going to convert a recurring decimal into a rational number or a vulgar fraction. The first example is express 0.6 bar as a vulgar fraction. So we are going to write let x is equal to 0.6 bar. Now this bar means that only 6 is being repeated. So we have written it to be like this. X is equal to 0.6666 so on, and we've marked this equation as equation number 1. Now in this case only one digit is being repeated. As we have already discussed, in case only one digit is being repeated, so we are going to multiply both sides by 10. So on multiplying both sides by 10, we get 10x is equal to, now for this right side when we are going to multiply it with 10, so the decimal will shift to the right side, one place to the right side. So it will come as 10x is equal to 6.6666 so on, and we are going to mark this equation as equation number 2. Now the last step that we are going to do is that we are going to subtract 1 from 2. So we are going to do the subtraction of equation number 1 and equation number 2, that is 1 from 2. So we are going to write 10x is equal to 6.6666 so on, and x is equal to 0.6666 so on. Now x means 1x. So when we subtract 1x from 10x, we are going to get 9x. The 6.666 minus 0.666 will give us 6.00, which we have just written it to be like 6 only. So we have got 9x is equal to 6. Now 9 will be shifted to the other side. So on shifting, we'll get x is equal to 6 upon 9. Now this is not in its simplest form, so we are going to do the cutting. So on doing cutting, we'll get x is equal to 2 by 3. So therefore 0.6 bar is equal to 2 upon 3. So let us discuss some more examples based on this topic. Example number 2 is express 5.36 bar as a rational number. So the first step will be we are going to write let x is equal to 5.36 bar. So in this case, there are two digits which are being repeated after the decimal. So we are going to write it to be like this. X is equal to 5.363636 so on. And we are going to mark this equation as equation number 1. Now in this case, there were two digits which were being repeated. So for that, we have multiplied both sides by 100. So when we multiply both sides by 100 of equation 1, we'll get 100x is equal to, now in this case, the decimal will shift to the right side 2 decimal places. So on shifting, we'll get 100x is equal to 536.363636 so on, and this will give us our equation number 2. So now we are going to do subtracting 1 from 2. We get 100x is equal to 536.363636 so on, and x is equal to 5.363636 so on. Now we are going to do subtraction. So now from 100x we'll subtract 1x, so it will give us 99x, and from 536 we'll subtract 5, which will give us 531. So now 99 will be shifted to the other side. So on shifting, we'll get x is equal to 531 upon 99. Now it is also not in its simplest form. So we are going to do the cutting. So after doing the cutting, we'll get x is equal to 59 upon 11. So therefore, 5.36 is equal to 59 upon 11. So let us discuss one more example based on the same topic. The next example is express 0.456 bar. Here the bar is only on the digits 5 and 6, not on 4, in the form of P upon Q. Here in this sum, one more step will be increased, as all the digits after the decimal in this sum, they are not being repeated. The first digit after the decimal, it is not being repeated. The other two digits, they are being repeated. So in this case, our first step will be that we are going to take out the number or the digit which is not being repeated outside the decimal first. Then we are going to take out the other two digits outside the decimal place. So for that, let us discuss how we are going to do it. So we are going to write let x is equal to 0.456 bar. So it will be written as x is equal to 0.4565656 so on, and this will be our equation number 1. Now here there is one digit after the decimal which is not being repeated, so we are going to take it out first. So that is one digit only, so we are going to multiply by 10. So on multiplying, we'll get 10x is equal to 4.565656 so on. This will give us our equation number 2. So now we are going to take out those digits out which were being repeated. Now in this case, there were two digits which were being repeated. So for that, we are going to multiply equation number 2 by 100. So on multiplying equation number 2 by 100, we'll get 1000x is equal to 456.5656, and this will give us our equation number 3. Now we have to subtract the last two equations that we have got, and those are equation number 2 and 3. So subtracting 2 from 3, we get 1000x is equal to 456.565656 so on. 10x is equal to 4.565656 so on. So now we are going to subtract them. So on subtracting 1010, we are going to get 990x is equal to, on subtracting 456 and 4, we'll get 452. So we get 990x is equal to 452. Now 990 will be shifted to the other side. So on shifting, we'll get x is equal to 452 upon 990. And this is also not in its simplest form. So we are going to do the cutting. So on doing cutting, we'll get x is equal to 226 upon 495. So therefore 0.456 bar is equal to 226 upon 495. Now students, you have got the sums based on this topic. So solve those sums. Till then, thank you and have a nice day.